Hello friends, in this video we are going to see about statistical inference, also called as inferential statistics. So what does this statistical inference means? It is a process of using a sample to infer the properties of population. For example, whenever we want to take any decision for a huge amount of data, it is very difficult to do that. So what will we do is, instead of doing it for the entire data, we will be choosing some sample amount of data from the huge data, and from in the sample data we will apply some data analytics statistics, and then we will make some decision, and that decision we extend to the population. So that is what statistical inference means. So it is a process of using a sample. In the sample, we do all the inference decision making. That inference is extended, generalized to the population. So in the statistical inference, we'll also use data analytics, statistics to do the decision making. What is this population? So here we are going to use two main terminologies, that is population and sample. What is population? Population means it is the entire group of the data, complete data. Entire group of the data. What is sample? From the entire group of data, we are going to choose some specific group from the full population, and to the specific group we will apply some statistics inference, and then we'll generalize it to the population. So here is the picture which demonstrates that. So we have the complete population here. Out of it, we are going to take the sample. In the sample, we apply some statistics data analysis, infer some from data about it, or do some decision making in the sample. That sample we will apply to the population, entire population. And we generalize it. Say, for example, if I am a scientist, I want to find the effect of energy drink to the entire children of the country. So it is very difficult for me to go and check it with every children in the country. So what I will do it, instead of doing analysis to all the children in the country, I will take some group of children. For example, we'll take some 500 children or 1,000 children or 300 children, whatever maybe, some sample from the all the populate, all the complete children. I'll take some group of children. In the children, I will see how much, what is the growth after having this energy drink, what is their immunity level, and how they are active. All these things I will infer from this group of children. And after I do the decision making, using that, I will generalize it to the complete population and say, after having this energy drink, the children are growing like this. They are so energetic. Their immunity is boosted. So I didn't do for the complete population. Instead, I did for the sample, and then I generalize it to the population. So always the population, the inference we did from the sample will not be exactly equal to the population inference we do with the population, but at least it will be similar. And to do this inference, first we are going to do it with the example of mean. One of the inference we can do is mean. So for that, what we are going to do is, first we are going to take a sample mean. Then using the sample mean, we are going to estimate to the population mean. So first we are going to take a small group of data. For this small group of data, I'm going to calculate the mean. With this sample mean, then I can able to estimate what will be the mean of the population. I hope you know what is the difference between sample and population. So the formula used to calculate the sample mean is, it's one second. So to do the sample mean, I have the formula is this. So x bar says the mean of the sample, which is equal to summation of all the data values of the sample divided by n. Small n represents the sample size. And capital N represent the population size, and mu represent the population mean, x bar represent the sample mean. So what I will do, first I am going to calculate the sample mean. After finding the sample mean, I can able to estimate the population mean. So this is the formula, we will find it. After doing this, now I want to generalize or estimate to the population mean. But the sample mean will not be always exactly matching to the population mean, as I already told you, because it's just an estimation, right? So what will I do is, if it want to be matched with the population mean, then I have to repeatedly do this process again and again, maybe infinite time number of time. At that times, the mean of the sample would be equal to the population mean. So if the sample is random and if the sample size is large, then the sample mean would be good to estimate the population mean. So first thing is we want to calculate the mean. After calculate the mean, we want to know the confidence interval. What is this confidence interval means? With the help of the sample mean, maybe x bar, I want to estimate the population mean, right? So I cannot exactly say this is what the population mean. Instead, I'll say the population mean will be ranging within this limit. So with the help of the sample mean, I can estimate the population mean, and I can say the population mean will be ranging within this lower limit and the upper limit. This is the lower limit and this is the upper limit. So to find that, we use confidence interval. So to find the confidence interval, we have a formula. This is the formula. Confidence interval is equal to x bar plus or minus set into S divided by root of n. So what is this x bar? We know it is the mean of the sample, and then S is standard deviation, and root of n. N is the sample size. Then what is a set? Set is called a set score. The set score helps us to, it is the estimation of number of standard deviation that an observation lies from the mean. For example, this is the mean means. What is the number of it is the estimation of number of standard deviation. So that is the set value. So find the set value, we will use a thing called confidence level. So generally, most popularly used confidence level is 90%, 95%, or 99%. Maybe like this. So if the confidence level is 95%, then what is the set score value? Set score value means what? It is an estimate of number of standard deviation from the mean. So to calculate it, we have a formula. I'll show you that. So what does this confidence level mean? It means that, for example, if I consider the confidence level as 95% means, it says that 95% of the time, our mean population will be lying between this lower limit and the upper limit. So mu, that is that the population mean. So I say that 95% of the time, my population mean will be ranging within this lower limit and upper limit, and that is calculated based on the mean of the sample. So let us take an example and we demonstrate it. Let's say an example. So we want to calculate the cholesterol level of the female. That is what the problem. So if I want to find for all the people across the country, it is very difficult. So what I'm going to do is I'm going to take a sample. So I'm going to take 97 female, and it is also given in the question, what is the standard deviation that, and what is the mean also. 261.75 is the mean, and the confidence level taken is 95%, which means what? 95% of my time, I can ensure that the population mean will be ranging within the lower limit and the upper limit when I take different samples also. So here, according to the question, I can say x bar is already given, that is the sample mean. This is the standard deviation, that is also given here, and n is the number of samples taken, that is 95 females. So these are the terms we want for this calculation, and then we want to calculate a z value. So how will you find the z value? We know the confidence level. So if the confidence level here, it is taken as 95%. If it is 95%, here you can see, then the Z value is 1.96. So we know that the set score value also, we know it is 1.96. So using that value, we are going to calculate the confidence interval. So when we apply all this value to this formula, we can able to get it. So to find the lower limit, so what will you do? We have to find the mean. So this one, we want to find the mean plus lower limit means we'll take minus mean minus set into S divided by square root of n. That is what here. Mean into plus mean plus 1.96. That is the set value. into what is this? 64.9 is the standard deviation, and this is the n value divided by square root of n. And to find the lower limit, this is the lower limit and this is the upper limit. So to find the lower limit, here we have given minus, and then we are applying all the values. So we know the lower limit is 248.83 and the upper limit is 274.67. So from this we can infer that 95% of time my population mean will be ranging within this lower limit and the upper limit based upon the sample mean. So that is what the inference we can get. So now almost we can able to infer, okay, my population mean will also be within this range only. So let's see this with an example. So here, initially, I'm going to take import all the necessary modules needed here. First, I'm taking pandas. Pandas help me to work with data frame, and stats module help me to work with statistics. NumPy help me to work with arrays. Here, I'm going to use NumPy for generating the random values. That is my sample value. And math help me to find the square root. And matplotlib help me to do the data visualization. So the first thing what I'm going to do is I'm going to read my data set, which is in the form of CSV. I'm going to use the data set to add to data set. And then after reading my data set and it is in the data frame format, I'm going to find a shape. Shape property will help me to find the number of rows and columns available in the data set. So here the number of rows is 1436 and the column is 37, which means 37 features are there, and the number of values, the population. So this is what the population is here. That is 1000 here. This is the population. So this is the population, this value. So population is 1436. So to get the population alone, we use this one, 0. So which means it will take me, help me to find that 0th value, that is the rows. So that is my population. Okay. So now what I'm going to do is from this population, I'm going to randomly choose some sample, and then we are going to calculate the mean, and then I'm going to say with the help of the mean, I'm going to say find the population of the population mean that lies under lower limit and the upper limit. So for that, I want some random values, right? To generate the sample, I'm going to use this random function, and I'm going to use this seed, and you can apply some with the help of the seed number. The random value will be generated. The value can be 6, 10, 12 or anything. You can try with different values. So if I give a seed value, I can know that I will get the same random number again and again. So next time when I run also, I'll get the same value. So now first time what I'm going to do is I'm going to take 500 sample out of 1436 population. I'm going to take only 500 sample, and for the 500 sample I'm going to randomly choose some values. So here from the data frame, I'm going to take only the price column. In the price column, I'm not going to take everything. I'm going to take only 500 values. And then for that 500 values, which is in the sample underscore 1, I'm going to find the mean. Okay, once the mean is ready, and we got the value as 10,890. That is the mean of this price, this column. Now, similarly, I'm going to take 1000 sample number as a sample, and for that also, I'm going to calculate the mean. So we can see this is what the mean for 500 sample. When the 1000 is the sample size, this is the mean. And let us calculate the population mean. So population mean, when I calculate for the complete value, the mean I got is 10,000. So this is actually the original mean value of the population. Now you can see when I take the sample of 500, it is also some nearly equal, right? Approximately equal to the population mean. When I take 1000 sample also, that time also I can say the sample mean is also approximately equal to the population mean. So from that we can understand when I do some inference from the sample, I can extend or estimate it to the population as well. So here we know the population because we know only 1436 rows are there. We can able to calculate the population mean, but in general real-time example we cannot do it. So just we are going to estimate it from the sample mean. So now what we are going to do is we are going to calculate the interval. After finding the mean, what will you do? We will find the confidence interval, right? So for that, first let us take the standard deviation. So if you look at this formula, we know what are the things we need. We want the standard deviation, right? So for that, we want calculating the standard deviation. Okay, then we want to find the set value. So this is a set value. If you want to know the set value, first we will consider the confidence level. So here the confidence level we take as 95%, and using this 95%, we have to mathematically calculate the set score value. Here we directly represented for 95% means it's 1.96, but mathematically we are going to calculate using this formula. Okay, and here we are going to take a round off it to 2 decimal places. So stat.norm.ppf will help me to find the set score value. So the set score value is calculated. Now our set score value is ready, standard deviation is ready. Now we are going to find the upper limit and lower limit. So first what we are going to do is, first this part we are going to do it. First we are going to calculate this part. So this part is called as error. So first we are finding the error, and then we can add it with the sample mean, and to get the upper limit, and we can subtract the error from the sample mean to get the lower limit. So that is what we are going to do here. First, we are getting the error part. What is the error part? Set score into standard deviation divided by square root of n. So that is what set score into standard deviation that we found already here, right? Divided by square root of S1. S1 is the number of samples. That is the 500 here. After finding the error with the sample mean, we'll add with the sample mean to find the upper limit. So we add to find the upper limit, and we subtract to get the lower limit. So now I know my confidence interval. And so here you can see this is a sample mean for 500 sample size, and this is the standard deviation, this is the set score value, and this is the range. And now since we know the population mean, we can understand my population mean is also falling within this upper limit and the lower limit. Similarly, with the confidence level of 99% also we can calculate. So which means what? 99% of time my population mean will be falling under the lower limit and upper limit. That is what the meaning is. Again, same thing after you apply, you can see when I apply for the 500 data sample, 99% as my confidence level, I get my sample mean as this, standard deviation as this. This is the set score. You can see here for 99%, what's the set score? 2.58. This is the set score, right? So that's what we got it here. And the confidence interval is lower limit is this, upper limit is this. So now also you can see our population mean. This is the population mean, which also again fall between the upper limit and the lower limit. So as we increase the confidence interval, the lower limit and upper limit also will expand. Now we can also check with 75% of confidence level, and we can check the confidence interval. So when I take 75% as confidence level, so this is what my confidence interval, and my population mean again fall within the upper limit and lower limit. Let us now check it with 25 trials. Okay, so here we did it for one time. Now we are going to take 25 times. We are going to take different samples of size 500, and then we are going to plot it, and we are going to visualize it, how my population mean is falling within the interval. So for that, I'm creating two lists to store the intervals, because 25 intervals I'll get, and also 25 means I'll get, because 25 times I'm going to run it with a sample size of 500. Every time I'll randomly choose some 500 values. So here the next thing is we want to find the confidence level. For the confidence level is 95%, we want to find the set score using the formula, and then we are finding the mean value of the population. Now, as of now, we can find it. Now, 25 times I want to run the same thing which we did here. Okay, same thing only here. So first thing, what you have to find, we want to find a randomly choose some 500 values. For that randomly chosen value, that is sample, we want to find the mean. After finding the mean, I'm going to append this in the sample mean, this list. And then we want to find the standard deviation. Using the standard deviation, we are first calculating the error, and with the that error is first subtracted with the sample mean to find the lower limit, then added with the sample mean to find the upper limit, and then the lower limit and upper limit is appended in this inside the list interval inside this. So we can repeat it for 25 times so that I'll get 25 values of this. Okay, so now first let us print only the sample means. So when I run it, these are the 25 sample means. So when I take 25 times, I take different 500 samples, and this is the mean. And then let us display the population mean. So this is the population mean. And then let us find the intervals. So when I find the interval, this is the 25 intervals. This is the interval for this value. So for this sample mean, this is the interval. And you can check, you can see that the population mean is obviously falling under this lower limit and upper limit. And for the second sample, this is the lower limit and this is the upper limit. And again, you can see this population mean is falling under this limit. So we have taken for 25 times. Now let us visualize it. For that, we have used error bar, where I'm going to give in the x-axis, I'm going to give the 25 trials we are doing, right? 25 times. So it starts from 1 to 25. If we give 1 here, it's giving error. So let us start from 0.1. And in the y-axis, we want the mean of all the samples. And for the intervals, we are going to find the upper limit and the top value and the bottom value, the lower limit and upper limit. And let us run this program now. So now we can initialize that for all 25 trials. For first sample, what is the mean value? What is the lower limit, upper limits? You can see here. For the mean, first sample, the mean is 10,463. So you can see 10,463. And what is the upper limit? 10,191. So you can see this is 10,900. What is it? A lower limit 191. Okay. So what is the upper limit for the first sample? 10,735. So 10,735. Similarly, this is for the second sample, lower limit, upper limit, and the mean. Okay. So for 25 samples of 500 size, we have found what is the mean and what is the upper limit, lower limit. Now, what is our objective? Using this, we have to check whether this, using the sample means, we have to check, we can able to estimate it for the population mean, which means we said that 95% of the time it will be falling under the lower limit and the upper limit. To check that, let us draw a line here. So that is horizontal line. So the minimum value is 0, maximum value is 25, and the y value we are taking as mean, population mean, and we are going to draw it. So when we are just drawing the mean of the population, and we can say more than 95% of the time, 95% of the time, my population mean is falling within this upper limit and lower limit based on the sample mean. You can see everywhere, most of the time, except this, we can see, and except this. Here also 95% of the, that is what the confidence level we have taken, right? See, confidence level is 95%. So 95% of the time we can say our population mean is falling within the limit, within the lower limit and upper limit. So this is about statistical inference using mean. Okay, now let us go to the next way of finding the statistical inference. The first one is correlation coefficient. And then we will discuss, followed by the covariance matrix and hypothesis testing. So what is correlation coefficient? Correlation coefficient means what? Correlation, the word itself we can understand. It will help us to find the relationship between two variables. So let us take two variables, age of the car and the maintenance of the car. So as the age increases, maintenance will also increase, right? So what is the relationship between these two variables? That is what we can find with the help of correlation coefficient. So generally for the correlation coefficient, the range will be between -1 to +1. And if it will not go beyond it, if it's going beyond it, it is an error. So if you get a correlation value of -1, then it's a perfect negative correlation. So -1 means it's a perfect negative correlation. If it's a +1, it's a perfect positive correlation. Let's see some example here. So if you see here, it's a perfect positive correlation, which means, let's take an example. For example, as the age of the car increases, the maintenance will also increases. So it's a, say for example, maintenance will also increase. So this will help me to find the relationship between these two variables. So here I can say it's perfectly positive correlation. And this is little bit, which means why I say it is perfectly falling in a linear line. So it is perfect. So which will be coming as +1. And here it is strong positive correlation, maybe like coming like 0.9 like that. And this is weak positive correlation, maybe near to 0, maybe 0.4, something like that, or 0.2. This is weak positive correlation. And here you cannot infer anything out of it. So it is no relation. So there is no relation between these two variables, whatever may be the parameter values. And here it is weak correlation. What is weak correlation means? For example, as the age of the car increases, the price of the car decreases, right? So that is what this kind of one value increase, other value will decrease. Here, both one value increase, other value will also increase. As the age increase, maintenance also increase. That is positive correlation. The negative means what? When the age increase and the price will decrease. So that is a negative correlation. And this is strong negative correlation. This is perfectly falling in a straight line, linear line. So here you can see from this 0 means no correlation, +1 is strong correlation, and the value which greater than 0.5 may be taken as strong correlation. And if the correlation value fall between this, it is weak correlation and weak positive correlation. Less than 0 means it is a negative correlation, and if the value range from -0.5 to 0 means it is a weak negative correlation. If it is coming here means it is strong positive correlation. And this is another example. So when the correlation value is 1, then we can say it is here when one value increase, another value also increase means then it is a perfect positive correlation. And this is strong, we can say. Here it is, there is not at all, no correlation at all. Say there is no correlation. And here it is strong, we can say strong negative correlation. Here you can say we can say this is weak, and here you can say a strong. Here I can say perfect negative correlation. So this is about correlation coefficient. So to find this correlation coefficient, we have different methods. One is using the Pearson's correlation. So using this Pearson correlation is also to find the relationship between two variables only. This Pearson correlation can be used whenever the relationship between two variables is linear, okay, which will be like this, linear. But it cannot be used when your relationship between two variables non-linear, may be like this. In this case, we cannot use this Pearson correlation. So this Pearson correlation will help me to find the strength and the direction. Direction means what? Is it positive correlation or negative correlation? And strength means how much it is positive correlated. That strength will also be obtained using this Pearson correlation. Okay, to find this Pearson correlation, this is the formula to find the Pearson correlation. To find the Pearson correlation between these two variables x and y, how to find covariance of x comma y divided by standard deviation of the first variable into standard deviation of second variables. This is the equation to find the Pearson correlation. To find the first value we want to find is covariance of x comma y. So how to find the covariance of x comma y? What is x and y? This is the two variables in which we want to find the relation. So it is sum of the xi means a particular data value in that sample, and this is the mean of the sample, and this is a second variable data value and the mean of the second value, okay, divided by n. N is the sample size, the total number of values in x comma y, okay. And using this, we can able to find the covariance of x comma y, then divided by the standard deviation of the first variable into standard deviation of the second variable. And this is one way of representing the Pearson correlation. There are many other, if you see somewhere, you can see this is another way of representing the Pearson correlation. This is another way of representing the Pearson correlation. In all the ways, you will get the same answer only. So this is the formula of this one, right? Covariance divided by the standard deviation equation. And the particular value by minus data value of first variable minus standard deviation. Mean of the first variable. Then second variable's particular data value minus mean of the second variable, right? The whole square. Square root of that will help us to give this value. So that is the standard deviation. So let us take an example and we'll see how we can do with the Pearson correlation. So let us take the two variable. One is x, another one is y. Maybe any other marks or age or anything. Some sample value we have take. So now we want to find the relationship between these two variables, x comma y. So what are the values we want? If I want to apply to this formula, what are the values I want? First, this is xi. This is next xi, this is single symbol, then yi. So then first I want to find xi minus x bar. So x bar we want to find. How will you find the x bar? X bar means what? Mean. So we have to add all this value divided by the total number of value. So that is 21.3 and the mean of this y is 64.1. So how will I find xi? It means 6 minus 21.3 is this value. And here this 12 minus what does it mean? 21.3 is minus 9.3. Then 13 minus 21.3 is minus 8.3. Likewise here y minus y mean. What does y mean? 64.1. So 45 minus 64.1 is this value. And then after finding this value xi minus x bar, yi minus y bar, what we want to do? We want to multiply this both. Right, so we are multiplying this value with this value. So minus 15.3 into minus 19.1 will give you this value. And finally, we want to find the sum of all. So we want to find the sum of all. We got it. Then what is the next thing we want to find? Xi minus x bar, the whole square. So xi minus x bar we already found. So for that we want to find the square. So minus 15.3 into minus 15.3 will give you this value. And here again yi minus y bar the whole square. Yi minus y bar we already know the whole square. So minus 19.1 into minus 19.1 you will get this value. So we found all the value individually. The summation we found here, and this summation here also for this value we want to find the sum. So that is also found. This is also found. Then we want to find the square root of we want to find the square root of this value and the square root of this value. So that only will help you to find this value, right? So after finding this value, when you apply to the Pearson correlation, we'll get this. So what is the upper value? So this is what the sum of all the value, that is 1172. So this is a value. That is the value here, right? Sum of all xi minus x bar into yi minus y bar. So that we found it and divided by square root of this value. And in this value square root of, so we got a 0.947. So this is, you can see from this is near to +1, right? So we can say it is a strong correlation. So whenever it is nearing to, so here according to this diagram, you can see whenever it is related to nearing to +1, it is a strong correlation. So from this we can understand that when I compare the relationship between x variable and y variable using the Pearson, I can say these two variables are strongly correlated. And the next method to find the correlation coefficient is Spearman. Spearman's rank correlation. Spearman rank correlation also called this Spearman rank coefficients of correlation or Spearman's correlation coefficient. And it is a non-parametric measure. What is this non-parametric measure? Here we are not going to use any mean. We are not going to find any standard deviation. Without this mean standard deviation or mathematical function, we are going to use only rank correlate. We are going to use rank, and with the help of the rank, we are going to find the correlation between the variables. So as I said earlier, Pearson will be used when the relation is in linear, and Spearman will be used when your relationship is in non-linear way. So that is what here it is. It is monotonically increasing and it is decreasing and there is no correlation. And so as I said, here it is a non-parametric measure, right? Non-parametric measure means we are not going to use any mean standard deviation and all. So how will we do is, let us take two example. Here we are going to take max and sines as two parameters, let me x value and y value, and we are going to find the relationship between these two variables only with the help of the rank. So what will you do first? First, let us take max. In the max, we want to rank all this value. So among all this, when I rank it, like here it is taken in the descending order. So the highest value, first one, then what is the second one? This is the second one. This is, I'm just sorting it out in the descending order. This is the third value, fourth value, fifth value. Similarly, for the science mark, we are going to give the rank in the descending order. So 48 is the highest mark, then 45, then 39, then 35, then 24. So just we rank these values. So this is the rank for x value and this is the rank for y value. Now what we have to find, we want to find D. What is D? The difference between these two ranks. So which means 3 minus 5, that is 2, minus 2. And then 5 minus 4 is plus 1. 1 minus 3 is minus 2. And then likewise, we have to find the difference between these two values. Then we want to find this d square. Okay, d square means the square of this. So 2 into 2 is 4, 1 into 1 is 4, 2 into 2 is 4, 1 into 1 is 1, 2 into 2 is 4. So then sum of all this, you will get 14. So this is the formula used for this spearman. Okay, 1 minus 6 into summation of all this value, d square value divided by n. What is n? The number of values. Okay, into n square minus 1. So when you apply here, 1 minus, what is 6 into, what is the sum? 14. So 14 divided by, what is the n value? Number of value here is 1, 2, 3, 4, 5, 5. 5 into 5 square. 5 square is 25 minus 1. So you get 0.3. So 0.3 means what? It is somewhat closer to 0, right? So it is weak positive correlation. Since it's a positive value, you can say it is a positive correlation, but we can say this trend is weak positive correlation. So, but if it is nearing to 1 means we can say it is a strong positive correlation. So now let us apply this for a data value, and then we'll see how it is working. So here first we are going to find the correlation using SciPy. So for that we have imported the statistics module, and we are going to use Spearman and the Pearson correlation. So for that, for example, I have first taken the x value as age of the car, and the second value is the maintenance of the car. As the age increases, the maintenance will increase, as I said. So first I'm just going to plot it out, plot the age and the maintenance. So from this itself we can understand, right? As the age of the car increases. So this is the age of the car. So as the age, this is the age of the car. As the age of the car increases, you can see the maintenance is also increasing. So here, what does this G represent? That is a color, and this is O represents the marker. Okay. So for example, if I give different marker as X, so I'll get this X mark. Right, likewise you can give different option, and if you change the color also, if I say R, you will get the red color. So and you can also give the line type. It's a combination of all are individual values combined together as a string. And if I give a dash, so you will get a dash line. So whatever pattern you want, that you can give as a third character. So it just so if it doesn't give anything, you'll get only the dots. So it just shows the relations. Now we plotted it. Now we want to find using the Pearson. So this just says color and what type of marker you want and what kind of line you want. So this three you can combine here and you can give us a single string. Now, using Pearson correlation, we are going to find the correlation between these two variables, age of the car and the maintenance of the car. So just we are calling, already we have imported this Pearson and Spearman, right? So just we are calling this function Pearson of these two variables. And just we are printing, so we can say it is a positive correlation. And again, using Spearman also, we are seeing using this calling the Spearman function, and then we are giving the x value and the y value. So you know that the Spearman will use rank to do the correlation. So that also is done. So that the value is, we got as 0.96. It's close to 1. So we can say it is a positive correlation. The next thing is we are going to find the same correlation using Panda's library. So for that we have just using the Panda and again these two variables. So just given as a series of Pandas. And then using the correlation function available in the Panda. So first I'm taking age of the car correlated with maintenance of the car using the method Pearson. So this is just with the help of Panda's library. Here same thing, age variable with the maintenance, we are going to find a correlation, and the method here we are using is Spearman. And if you see in both the ways, you will get the same value. So here also 0.93, using the Pandas also you will get 0.93, and the Spearman 0.964, here also 0.964. So this is how we will be able to find the correlation between two variables using this Spearman and Pearson correlation. The next thing we are going to, next statistical inference method is covariance matrix. This is the next method. What is this covariance matrix is? This covariance matrix is also called as variance covariance matrix. So it is like a matrix, square matrix. Square matrix means what? It will have equal number of rows and columns. This will help you to give the covariance between each pair of elements. In correlation coefficient, what we'll do means we'll find the correlation between only two variables. But using covariant matrix, we can able to find the covariance between each pair of elements. For example, you see this example. Here, we are not only having two variables, we have three variables. So it will help you to find the covariance between each pair, age with experience, age with salary. So every pair of the data set, we can able to find the covariance. So correlation means, you will be is calculated based on the covariance. Covariance means what? Correlation means, it will help you to find the relationship between two variables. Covariance means it will help you to find the variance between two variables. Correlation always lies between -1 to +1. Covariance will be ranging from -infinity to +infinity. Okay, it will be any number within this range. So positive value means you can say positive correlation. Negative value means you can say negative correlation. So this correlation matrix will help you to give, covariance will always help you to give the direction along. Correlations will help you to get the strength as well as the direction. Okay, and this covariance matrix is a square matrix. Square matrix means what? Rows and the column values will be equal. And variance of the variable. Okay, now let us see this, what it means. For example, here I have given two tables. Okay, so this you can see this diagonal value, this diagonal value represents, that's what represents a variance. So this we say diagonal values, we say as variance. And other values, this and this value will be similar to this symmetry. Okay, symmetric matrix this is, and this value will be here, and this is this value. So whatever above the diagonal and the below the diagonal value will be same. So that's what is a symmetry, and the diagonal values will be called as variance. All the other values we call as covariance. So see, covariance of the variable, and all other values are the covariance of the variable. So diagonal values, which means age and age. Between age and age, it is variance. Experience and experience, it is variance. The other values are called as covariance of the variable. And here you can see between age and the salary, we are getting a negative value. So it is what? Negative correlation. Okay, negative covariance value. And here you can see age and the salary, this positive value. So this is positive. So this is an example for negative correlation, and here is an example for positive covariance. Okay, so now let us check it with a code. So here I have again use pandas library to find the relationship between these two, this different features. So here I have created a data frame for age, experience, and salary. So here I have given as the age increases, the salary is decreasing, right? So if one value increase, another value decrease means it's a negative correlation. So that's why you can see here I'm getting the negative value. As the age increase, I get the salary is in decreasing, value is decreased. So it's a negative correlation. So if you're getting a negative value, it's a negative relationship. Okay, and that is calculated by df. What is data frame? This is the data frame dot covariance. Covariance function help us to get the covariance of all these values. And the positive correlation, here I have given the value as the age increase, the salary is also increasing. See, so that I get the value here as positive. So we can say it is a positive relationship. So that is about covariance matrix. The last thing is hypothesis testing. Using hypothesis testing also, we can able to find the statistical inference. So what is, we know what is statistical inference, right? We'll take a sample, in that we do some analysis, and we do some inference and decision making, and that we will generalize to the population. And what is this hypothetical testing means? When we do the experiment with the sample, we will do some claims, right? Claims. That claims, for example, this is like this. This mean will be like this. So we do some claim. That claims we call as hypothesis. And this claims, we want to prove it for the population parameter also. So that is what called as hypothesis testing. So the claims which we raise is hypothesis, and the hypothesis is a form of statistical inference that use as data from the sample to draw conclusion about the population parameter. There are two types of hypotheses are there, null hypothesis and alternative hypothesis. What is null? We'll see all with examples so that you'll understand. Null hypothesis is the assumption about the population. The opposite of the null hypothesis is alternative hypothesis. Let's see with the example, you'll understand. Let's see an example. There is a statement. Okay, so we want to prove it. What is the that want to prove? All adults on average sleep 7 hours a day. That is what the statement. So this is what. So I want to check throughout India. Well, is it possible for me to go and check with every individual, every adults of India? No, it's not possible. So here the claim is, what is the claim? All adults on average, they sleep for 7 hours. That is a claim. Sleep for 7 hours is a claim. What is the population? All adults. So it's very difficult for me to go and do the inference for all adults. So what will do? I will take a sample out of this adults and I'll apply all the statistical analysis, whatever I want. And I will extend it to the population. And here the claim is they will sleep for 7 hours. That is the claim. Okay. So okay. Now, on like what is my null hypothesis, what is the assumption about the population is they will sleep for 7 hours, but when you calculate you are getting 7.5 hours, okay, for the sample mean I'm getting a 7.5. Then how will I generalize it? How will I take the decision? To take the decision, we are going to use set score. Let's see with another example. See here, there is a statement. A principal of a school claims that all the children in their school are above average. So this is what the claim of the principal. What is the claim? All the children are above average. Okay, above average intelligence. So this is what the claim given by the principal. And the random sample they are taking is for, so sample value they are taking it for only 30 children, okay, 30 students, and IQ score, and have the mean. What is the mean they have found here is for the sample is 112.5 and the mean of the population is 100, okay, and with the standard deviation is 15. Is there sufficient evidence to support the principal's claim? Now we have to prove whether the principal claim is right or wrong. That we have to do it with the we have to prove it. So to prove that, we are going to use null hypothesis and the alternative hypothesis. So now what we understood from the population? From the population we understood the mean. Using mean we are going to do it. So from the population we understood that the mean is 100. So that is called as null hypothesis. So the first step to prove that is we want to find the null hypothesis. The opposite of that is alternative hypothesis. So the reality is what is actually the first step? The set test to do. So set test will help you to prove it. So to prove that, first thing we have to find is null hypothesis H naught. And this is what you want to believe. This is what is the belief for the mu, it is 100, and we want to take that as a null hypothesis. The opposite means what is the principal's claim? They said it is above that, so it is greater than the you can see the mean value is greater than this value. So our alternative hypothesis opposite of that. So alternative hypothesis, I am taking the mu is greater than 100. So that is what that we got it. Now we want to prove which is true. Okay. So for that, we want to first determine, the next step we want to do is we want to determine the level of significance. Level of significance is said to be as alpha. This alpha is somewhat similar to the confidence level we did there already. Okay, we already saw what is confidence level when we calculated the mean, right? So here in this test also, the confidence level is similar to the alpha value, that is the level of significance. To find the level of significance, we use a critical value. Okay, so we will see how the critical values calculate. So the set test only determine if there is a significant difference between sample and a population mean. That's what set test will help us to do. So what is the formula for the set test is mean of the sample minus mean of the population divided by the standard deviation and divided by root of the number of samples. Okay, so now from this question, which I told already sample, what does the sample mean already given in the question? Sample mean is 112.5. And what is the population mean? Population mean is given as 100. What is the standard deviation? Standard deviation is 50. How many number of sample is taken? 30 is the sample taken. Okay, this is all given in the question. Now let us take significance level alpha equal to 0.05. Like here, like as we saw in the confidence level, right? 0.05. It's like 95% we took for confidence level, which means 95% of the time we will be getting the same thing. Same thing here also. Here we take a significance level, that is 0.05. And the test value we get here, that is the critical value we get here, is 1.645. So for the level of significance of 0.05, this is what the one-tailed test value we get. So that is a set score value. So for the level of alpha 0.05, this is the test value you will be getting. Now we are going to apply this to the this values to the formula. When you apply, same thing, when you substitute all this value, you will get the z-score value as 4.56. Now, using this set value, we want to prove it. Which hypothesis is correct? So what is the calculated value? The calculated z-score value we calculate is 4.56. And if the calculated value is greater than the set critical value is this value. Okay, for this level of significance, what is the critical value we got? This will, you would have learned in the school days maths, right? The set value, so this is the 1.645 is the critical value. So if the value which we calculated is greater than 1.645, it is greater than the z critical value, which is this value, then we can say that we can reject the null hypothesis. What is the null hypothesis? That is when you, that 100, right, the mean of the population. Then we have to accept the alternative hypothesis. If the calculated value is greater than the z critical value, then we have to reject the null hypothesis and accept the alternative hypothesis. What is alternative hypothesis? Alternative hypothesis, what the the principal said is correct. Okay, this is actually null hypothesis. Since the value of z value which we calculated is greater, then the alternative hypothesis is true. If the z value we calculated is less, then the null hypothesis is true. So now we can say, so whatever the principal claimed is correct, that is, the school students are above average intelligent. Let us implement it now. This is the value, the same thing, no, covariance matrix we did with NumPy. You can just go through it. NP dot covariance of this A. So here also same function, covariance here also. Now let us check it for the hypothesis testing. As we did. So same question. Now, sorry. Now here, according to the question, the sample mean is 110. The population mean is 100. The number of samples which we taken is 50. The standard deviation is 50. Now from this, we can calculate the z-score value. We know the formula for this. This is the formula for the finding the z-score value. When we apply the same thing, what is x bar? We know 110. That is the sample mean. And minus mu value, that is the population mean, divided by the standard deviation divided by square root of n. The same thing. When we apply, and we got the z value. So now we are going to check whether the calculated z value is greater than the critical z value. Then we can say reject the hypothesis. Reject the null hypothesis and accept the alternative hypothesis. Alternative hypothesis. Okay, so now we are going to say we are going to reject the null hypothesis, and we are going to say what the principal said is correct. And the value which we got for the z value is 4.714. So this is how we can able to prove using. So the claims which we make, we want to prove whether the claim which we made is correct or not. And we can test it using this hypothesis testing. Hope you get understand. So using this different methods, we can able to get a sample, do some analysis over it, and the inference which we get from that will be extended or generalized to the population. Hope you got it. Thank you. God bless you.